Hi, here we are again. This is week 3 still, and hopefully you've looked at the supervised classification activities tasks. Today, or in this video, I'm going to be looking at file I/O, and then after that we're going to look at how to do scatter plots and other types of graphs in Python. So the rest of these, the next 2 videos are Python videos, and then we'll have assignment 1B. If you take a look at week 3 in here, these are the supervised classification activities. This is the example code for week 3. I don't have a handout for this per se, but I'm going to be going through the example code and looking at some exercises. There is a reading that goes along with this. If you go in under resources here, where is it? Selections from data science from scratch. So if you click on that, you can download it, but let me just show you what it looks like over here. Machine learning. Here we are. Boom, boom. So this is a textbook. It's written in Python 2, which is not that big of a deal for what we're looking at here. I kind of took out of this as much as I was legally allowed to for you guys. I don't think there's any bookmarks or anything. No, that would be too easy. But if you want more information on what we're doing in this class, you can come in here. There is a first chapter on basic Python stuff. Then there's chapter 3 on visualizing data, which we'll actually look at next time. But right now, what I want you to look at, or the stuff that we're going to be covering, is in chapter 9, getting data. So this covers input from standard input, output to standard output. You can ignore that section. You'll notice the print statement doesn't look right here. The input's a little bit different too when you're going from Python 2. And skip right down to reading files. So this is the stuff that we're going to cover right now. Reading and writing files. Oops. So where am I? Here I am. So in the example code for this week, you'll find a few things. Let me go back to the desktop here, into the example code. There's a bunch of files here. The first one we're going to look at is plainio.py. Get rid of this one. And it just kind of shows you how to read plain text files. We're not going to do a lot of that, but I thought I would show it to you because it illustrates some of the basic ideas and the basic sort of syntax of what we're going to be doing. First thing I'm going to do is I'm just going to run this file. What it does is it reads data in from hello world, the hello file. So there's a hello.txt file here, which contains hello world, did it work? It reads and outputs that data, and then it opens goodbye text for writing. So if I delete this, you'll see that it's not there, and if I run it again over here, it has created a file called goodbye.txt, which just says this is line 1 and this is line 2. So we won't be writing to files that often, but it is a good little trick to have. A lot of the programs we write will be long and will take a long time to process. It's not a bad idea to put things into a log file. It's not really required, but we'll go over this stuff anyway, and it will give you a basis to move on to the next thing, which is reading from a CSV file, which is much more like what we'll be doing most of the time. So what I've done here is I've created a read file function, and then I call it using hello.txt as the file name. When you're reading text files, if you've been running your scripts in other ways, you really have to run file as script. What that does is it restarts the kernel, and then it restarts the shell, the kernel process. Then it goes to the file and runs the script that you've saved in the file itself, from the file itself. And what that does is it sets the working folder so you don't have to go looking for files. The file will be right there, as long as it's right there in the same folder. So I'm reading from hello.txt. So the fact that I did Control-Shift-E instead of some of these other options means that I can just say hello.txt as the file name, and it will load the hello.txt from right beside it. Otherwise, it won't know where to find it. Now that I've done this, now that I've run the script, I can show you just some real basics. So file equals open file name being here hello.txt. Okay, so that creates a file object. You can see it's a text IO wrapper. It's also a thing called an iterator. So now if I go next file, it will give me the first line of the file and the next line of the file. And when it gets to the end, it throws an exception. Okay, so if I start that process again, if I open the file again for reading, and then I go, let's say line equals next file. So now line is the first line of the file with the carriage return in there. If you want to split it up into separate words, which eventually we will be doing stuff like that, you can say line.split. So this split is a method of any for any string that does this. It throws away white space and it splits along the white space lines. You can also specify separators that will get rid of the punctuation and stuff like that, but this is the basic idea. So now that you know how that all works, let's take a look at this syntax. This is a really handy syntax, this with statement. So you can say open the file name and assign it to the variable file. So that basically just does this. I'm saying with this thing as the variable file, do the following code. So the indenting is here. So it's using its open file name for you. It's put it into the file variable. And the nice thing about using the with statement is that it will automatically close the resource at the end. You do need to close files when you're done with them. When you're opening them for reading, which is the default, it doesn't really matter. But when you open them for writing, if you don't close them, it might not flush everything to the file for you, and it might leave the file locked. So the with statement is nice because you can then just use file without having to worry about closing it. Since file is an iterator, so I showed you there's this function called next that will get the next thing from the file, in this case a line. If you have an iterator like file, you can also use it in a for loop as if it was just a list of lines in the file. So I just say for line in file, and then I wanted to print it out one word at a time. So if I run this again, just to remind you, it prints out the file after splitting the lines into words. I just say line.split, which creates that list of words, and then I just say for every word in that list, print it. So that's what's going on there. Okay. When I go to write the file, I have a little function here, a little function called write file. It takes a file name and a contents. It's doing the same thing, except when it opens the file, it puts a W in there. W is for write. What that will do is it will blank out all the stuff that's currently in the file, if there is one, or it'll create the file if it needs to create the file, and then it goes through contents here. Here we are, is a list. I'm sending in a list of 2 lines here. I could add a third one to it if I want, like that. It goes through every line and it does file.write. I have to append the carriage return onto the end. So it goes through the contents list and just writes all the lines. So if I run this again, and then we take a look at goodbye.txt, there you go. You can actually load this into here. It's just a text editor, so you can take a look at it here. And the nice thing about that is if it changes, Control-Shift-E again, if I go back here, it tells me it's changed, and I can reload it and see the new version of it. Okay, that's all I really want to do here. The last thing here, what it does is this last function goes into a file called spam.txt, spam file. Wait, let me open this file in here as well. This is a file of, what was it going to let me? Might be a bit big. Okay, sorry about that. I don't try to open the spam file in Paizo. It'll crash it. Notepad++ can handle it though. This is just a file of real email that you can use that somebody put online along with a bunch of other spam files. And you can use them to test your spam filters and stuff like that. So that's just a big file of raw email. And the last thing that plain.io does is it counts the word best using this little count spam word function. It just goes through the entire file looking for the word best. And it says it appears on 3,716 lines. Okay, so I'll let you take a look at that in your own time. We don't have to worry about that for now. But the basic idea is opening files using the with statement. Files are iterators, so you can go through them line by line. Now, here's a file. This is cities.csv. So CSV stands for comma separated values. And you might notice that when I've opened it here in inside the Paizo, but if you might know that if you double click a CSV file, usually if you've got Excel installed, Excel will open it and show it to you. But what it is it's a raw text file where there's lines of data, and on each line, the different bits of data are separated, usually with a comma, but not always. Sometimes it might be another character, but it would still be called a CSV, comma, separated values file. When you look at it in Excel, it cleans it up for you a little bit, puts it into columns, and takes out the commas. But when you save it, it'll put the commas back in as long as it's .csv. This is much more like what most of the raw data files that we're going to deal with will look like. This is just a list of cities, a city number, a name, a region. This is the city of Kabul in Afghanistan. I believe that's the region. I can't remember. And this is the population. This data is old. It goes back to at least the 80s, I think. It's a really old data set that people use for teaching databases. So a lot of times we're going to want to read from this, and it would be a pain to have to try and take apart the commas ourselves and figure out where everything is. So our machine learning data will look a lot like this when it comes in, be data in columns. So fortunately, there's a CSV module that you can import that will do stuff for you, and let me show you how it works. So I have run this using Control-Shift-E, and it's done its thing. But I want to go through line by line. Now that it's been run, I can open the files just like I did before. So you'll notice here the same thing. I open cities.csv with the with statement, but I can also do it this way, like that. So I open the file, and then the file, it's an iterator. And then there's another step, though, which is to create a reader. And you have to import CSV for this, which I've already done, but I'll just show it here. You have to import CSV to... since I ran the script, I've already done that into this shell. And then I can say reader equals csv.reader file. And you can also specify a delimiter, which you probably should do. I think the default is comma, but I'll specify it anyway just to be sure. So if you had a file that was separated, where the values were separated with, for example, bar characters, you could put that there, and it would read the file that way. So I do that. Now I have created a reader, and the reader is also an iterator. So I can go next reader, and it gives me the next line. And you see what it's done. Because it's a CSV reader, it's read that first line of the file, but it's given it to me as a list, separating along the commas. And every time I say next, it gives me another line. So I could say something like row equals next reader, and that gives me the next row, which will be city number 4. And then if I know what each column means, so I can say row 1, for example, to get the name of the city, row 2 to get its region, and row 4, I think, to get its population. Notice, however, it is all coming in as strings. So if you've got numeric data, you might have to do some conversions to get that into the format that you want. Remember, you can always just use the name of a type as a function to turn the thing that you've got into, excuse me, into an integer or a float or whatever. So that's the first one here. Now, when I've done it here in the code, I used the with statement again, and I used a for loop to take advantage of the fact that a for loop can work on an iterator. The for loop calls next automatically and assigns it to row one by one until there are no rows left, and then it stops. So this first function here, when I run it, prints out all the city names. That's the city names. Whoops. Okay, so it's pretty straightforward. You just have to know the structure of your data. I wanted to show you one other way to do this, though. Cities2.csv has a header row that tells you the names of the columns. So if you open it up in Excel, you'll see that there's a row up here that tells you the names of all the columns. So that first row is not data, it's column names, and then you've got the data other than that is the same. There is a different kind of reader that you can use for this, also in the CSV package. So you import CSV, and then you go file equals open cities2.csv. This is the one with the header. Okay, now I've got the file, and then when I create the reader, I make it a dict reader. So it reads using a dictionary, and with a comma as a separator. And then when I go next reader, I get this. Now this is a dictionary. So you see what it's done is it's immediately gone and read the first line, which contained the column names, and it's using them to create a dictionary. So now if I go row equals next reader, I can use the column names to retrieve things. So row name, Kandahar. Row district, also Kandahar. Row population. Okay, you still have to do some conversions to get things from strings to integers and so on, but that's not that hard to do. So yeah, the code that looks like that over here, what I've done here is I've created a new list called codes. So this thing stores all the country codes. It goes into the reader. It checks to see if country code is in codes already. And if it's not, then it prints the country code and then appends it to the country code list. So at the end of this, I have a codes list. And as I'm looking at that, that should really be a set, shouldn't it? That should be a set. Then I don't even have to, that'll make it a lot more efficient, a bit more efficient, because I will be looking for, let's see if that works. I think it's not append. If I have a set called codes dot, it's add. So really, when you are repeatedly checking to see, so if I look at codes now, it's a set with those things in it. If you're repeatedly checking to see whether an item is in a data structure, you should probably be thinking about using a dictionary or a set. So I should have used a set there. I caught myself. All right, that is it for the basic idea. Now, there are other ways to read from files. There are standard packages that data scientists use to read from files. And I'm not saying don't use them, but they are a bit more complicated. This is very simple and gives us pretty complete control over it without having to worry about whether it's trying to be too intelligent and do things that we don't want it to do. It can be difficult to get some of those packages to do exactly what you want them to do on every data set. So this is kind of where I show you as a starting point. If you want to investigate other ways to read from files in a machine learning context and manipulate the data, you can certainly do that. I'm not going to stop you. But this is the baseline that we'll all use. If we go over to the exercises, here they are. Just take a look at 1 and 3. So write a program that reads these things. Use a dictionary to add up the total population of each country. So create a dictionary, and each dictionary should have an index for each country, and then add in the population of each country. Then output it in alphabetical order. So you use the int to convert the population strings to integers. You can use this, dict.items gets each item in the dictionary as a tuple, and you can put them into a list and sort a list of tuples, and it will sort by the first item in the tuple. Okay, so you've got a dictionary that that stores beside each country name the total population. So you're adding up the population of all the cities to get the populations of the countries. Never mind about number 2. Number 3, if you have time, read cities.csv, print the largest, smallest, average, and total population, and then print the names of the 10 biggest cities. And for that, I want you to use NumPy. Okay, so this is a good one to try as well. Probably maybe even a good one to start with. So I want you to read them in, convert to a NumPy array, and then print that, or to NumPy arrays, parallel arrays, and then print the names of the 10 biggest cities. So start with number 3, and if you have time, do number 2. I think number 3 is maybe more directly related to what we're doing. Okay, that's it for now. I will see you in the other video, the last video on scatter plots and graphs. Then there'll be an assignment video.